Welcome to this exploration of Python's functional programming tools. Lambda, map, and filter. These powerful features allow you to write more concise, expressive code by treating functions as first-class objects. Today we'll learn how to transform loops into elegant one-liners. Lambda functions are Python's way of creating small, anonymous functions on the fly. They're perfect for simple operations that don't warrant a full function definition. Let's start with the basic syntax and see how they compare to regular functions. Here we see the same functionality implemented both ways. The regular function uses the def keyword and a return statement. The Lambda version is more compact. It uses the Lambda keyword followed by parameters, a colon, and the expression to return. Notice how lambdas can be assigned to variables or used inline. Let's break down the Lambda syntax. It starts with the Lambda keyword, followed by parameters separated by commas, then a colon, and finally the expression to evaluate and return. The expression is evaluated and returned automatically, no return statement needed. Lambda functions are versatile but have important limitations. They can only contain expressions, not statements. This means no assignments, no print statements, no loops. Let's see what you can and cannot do with lambdas. Here are valid lambda examples. Notice how they all contain single expressions that return values. You can use conditionals, method calls, arithmetic operations, and work with multiple parameters. Lambdas excel at simple transformations. Now here's what you cannot do with lambdas. No variable assignments, no loops, no multiple statements. While you can call print, it returns none, which is really what you want. These limitations keep lambdas simple and focused. The map function applies a given function to every item in an iterable. Like a list, it's perfect for transforming data without writing explicit loops. Map returns an iterator, so you typically convert it to a list to see the results. Here's how map works visually. We have input data that gets fed through our Lambda function. Each element is transformed individually, and we get corresponding output values. Map applies the function to each element and collects all the results. Let's see map in action with various examples. Map can work with any function, whether it's a lambda, built-in function, or custom function you've defined. Here are comprehensive map examples. The basic usage transforms each number by squaring it. Map works great with built-in functions like str, upper. You can map over multiple iterables simultaneously. The lambda receives one argument from each iterable. Map excels at type conversions, like string to integer, and you can perform complex transformations, like extracting and modifying values from dictionaries. Important note: map returns an iterator, not a list. This is memory efficient for large datasets. But you need to convert to a list if you want to see or reuse the results. Iterators are consumed once they're used. While map transforms every element, filter selects only elements that meet certain criteria. It applies a function to each element and keeps only those where the function returns true. This is perfect for data filtering and selection tasks. Here's filter in action. We start with numbers 1 through 8. Our filter function checks if each number is even. Green boxes show numbers that pass the test. Gray boxes show those that don't. Filter keeps only the numbers that return true, the even ones. Watch as filter processes each element. Even numbers get green arrows showing they pass through to the output. Odd numbers get red X marks showing they're filtered out. Only elements that satisfy the condition make it to the final result. Let's explore filter with practical examples. Filter works with any function that returns a Boolean value, making it incredibly versatile for data selection tasks. These examples show filter's versatility. Basic filtering selects even numbers. String filtering finds words longer than 5 characters. Using none as the filter function removes all falsy values like empty strings, none, and empty lists. Complex filtering can combine multiple conditions with Boolean operators. You can filter any data type with appropriate conditions. The real power emerges when you combine map and filter. You can chain these operations to create elegant data processing pipelines that filter, then transform, or transform then filter your data in clean, readable one-liners. Here's a data processing pipeline. We start with numbers 1 through 10. First, we filter to keep only even numbers. Then we map those through a squaring function. This gives us the squares of all even numbers in our original list. Here are 3 ways to combine operations. Method 1 uses separate steps for clarity. Method 2 nests the operations. Filter produces input for map. Method 3 shows different ordering possibilities. The complex pipeline demonstrates real-world usage. Filtering students by criteria, then transforming the results. Each approach has its place depending on complexity and readability needs. Let's see how Lambda, map, and filter solve real programming problems. These tools shine in data processing, text manipulation, and any scenario where you need to transform or filter collections of data. First, data processing and cleaning. This example processes CSV-like data by stripping whitespace and splitting on commas. We extract specific columns with type conversions, like converting age strings to integers. Complex filtering finds senior engineers by combining job title and age criteria. Second, text processing and analysis. This extracts error messages from log files by filtering lines containing error, then mapping to extract just the message part. The word frequency example counts occurrences and filters for common words, demonstrating how functional techniques handle text analysis elegantly. Third, API response processing. This is common in web development. You receive JSON data and need to filter and transform it. Here we find affordable, available products and format them for display. We also extract IDs of expensive items for further processing. These patterns appear constantly in real applications. While Lambda, map, and filter create elegant code, there are important performance and readability considerations. Let's compare different approaches and learn when to use each technique for maximum effectiveness. Performance varies by use case, but list comprehensions are often fastest for simple operations. Map and filter add function call overhead but remain readable. Traditional loops are sometimes slower due to repeated append operations. The differences are usually small unless processing very large datasets. Here are key best practices. List comprehensions excel for simple transformations and are often more readable. Use map and filter when you have complex functions or when readability benefits from functional style. Avoid Lambda for anything complex. Write a proper function instead. Generator expressions save memory for large datasets. Even in Lambdas, use descriptive parameter names. Break complex chains into steps for easier debugging and maintenance. Let's compare the same operation written in different styles to understand when each approach shines. Readability often trumps minor performance differences. Here's the same great processing logic in 3 styles. The traditional loop is verbose but very clear about the step-by-step process. The functional approach separates filtering and mapping concerns clearly. The list comprehension is concise while remaining readable. Each has its place depending on complexity and team preferences. Each approach has trade-offs. Traditional loops are explicit and debuggable but verbose. Functional approaches separate filtering and transformation concerns but add function call overhead. List comprehensions are concise and often fastest but can become dense with complex logic. Choose based on your specific needs and team coding standards. Let's examine common mistakes when using Lambda, map, and filter, and learn how to avoid them. Understanding these pitfalls will make your code more robust. Here are key pitfalls to avoid. First, forgetting that map and filter return iterators, not lists. Always convert to list if you need the actual values. Second, iterator exhaustion, once consumed. Iterators are empty. Third, overly complex lambdas hurt readability. Use proper functions for complex logic. Fourth, avoid side effects in lambdas. They should be pure functions that just return values. Some pro tips. FuncTools. Partial creates customized functions from existing ones. The IterTools module provides advanced iterator tools. Using none as the filter function removes all falsy values. Map can work with multiple iterables simultaneously. The operator module provides functions for common operations, often cleaner than lambdas. Let's conclude with a comprehensive example that combines everything we've learned. We'll process sales data using Lambda, map, and filter in a realistic scenario. This example demonstrates a complete data processing pipeline. We filter for high-value sales, map through bonus calculations, group by representative, and filter for top performers. Each step uses functional programming concepts we've covered. The pipeline is readable, maintainable, and demonstrates real-world usage of these powerful tools. Let's summarize our journey through functional programming in Python. Lambda functions create anonymous functions for simple operations. Map transforms every element in a collection. Filter selects elements meeting criteria. Combining these creates powerful data pipelines. Use lambdas for simple operations. Proper functions for complex logic. Remember that map and filter return iterators. Most importantly, prioritize code readability over showing off clever one-liners. Remember, the best code doesn't just solve problems, it tells a clear story about what you are trying to accomplish. Lambda, map, and filter are powerful tools, but use them judiciously. Clean, readable code that your future self and teammates can understand is far more valuable than the most clever one-liner. Master these tools, but always prioritize clarity and maintainability in your Python programming journey. Thank you for joining this deep dive into Python's functional programming features. Practice these concepts with your own data. Experiment with different combinations. And remember that the best code is not just functional, but beautiful and readable too. Happy coding!